In this video, we'll take a look at how to generate MongoDB queries using OpenAI by passing in the input data and the expected output data and letting the AI generate the query for that. Alright, I would like to start with Mongo Playgrounds, a tool that I use frequently to test my queries when I'm working on a problem. This is the motivation behind the example that I'm going to walk through using OpenAI. Here I'm using the data that I'll be using later in the example. So this is a simple JSON array containing three objects, each object containing two attributes, name and the team, the player's name and the team that they belong to. And I have a simple query here. What I'm trying to do is to group by team and count the number of players in each team. So the query is simple. There's a group stage here, and I'm grouping by the team attribute and summing up the players and then projecting it out. So you get an output like this, each team and the number of players within each team. So in this example, what we are trying to do is we will give AI this input data and the expected output data, and then we'll ask it to generate this query. So that's the example that we'll see using three different ways. One, to start with using chat completion API directly, and then we'll use function calling with chat completion API, and then we'll use assistance API to do the same thing. We'll start with chat completion API and see how to generate the MongoDB query given an input data and the expected output data. Let's import the packages that we require. I've stored the OpenAI API key in a .env file locally, and I'm loading it as an environment variable here and instantiating a OpenAI client. I've got two models, we can use whichever we need, and define two prompts that we require, the system prompt and the user prompt. System prompt is very straightforward. We are instructing the AI that it's a MongoDB expert, which has got great expertise in writing MongoDB queries. And in the user prompt, we are accepting input data, output data. This is the one that the user would pass in. And here we are instructing that we need the AI to produce specifically an aggregation pipeline. We do not want the find query or anything of that sort. We always want the aggregation pipeline as an output, and also that we want a JSON response. So within the JSON response would have two fields, MongoDB query, the actual stages of the aggregation pipeline without any prefix or anything of that sort, just the array of stages and an explanation of that query that it produces. Finally, we pass in the input data and the output data that we get from the user. Let's run it. Now a small utility function is written to invoke the chat completion API. So first, we're getting the input data, output data. We're getting the system prompt, we're getting the user prompt, and passing in the input data, output data got from the user. And creating a messages array. First message is the role system, passing in the system prompt. Second message is role user and passing in the user prompt, this one. Now we're calling the chat completion API model, whatever model we either passed in or the default GPT-3 model that we are using. The messages array that we created here, temperature 0. We wanted to keep it 0 because we wanted to produce accurate output. So we're keeping it to 0. The response format, this is the new thing that we got last November. So we have instructed the assistant to produce a JSON. So we are forcing it to always produce a JSON by passing this response format. So simple function just to call the API and get the response. Here's the data that we saw earlier. Three objects, name and team, and in the output data, the team. Let's put it in quotations. The team and the player count. We are grouping by team and getting the number of players in each team. That's the output that we expect, and we are going to ask the AI to write the query for us. So let's run it. Finally, we are calling the utility function, passing in the input data, the output data, and the model. Okay. It is able to produce the same exact query that we saw on the Mongo playground. It is given the two stages: groups by team, sums of the player count, and projects it out. And then it also gives us a beautiful explanation of what it did. So this is cool. It reduced the query. Thing that we do not know right now is that whether this query would exactly produce the expected output data that we gave. There's no way for us to check unless we take this output and put it in the Mongo playground and again test it out. Instead of that, in the next step, we'll see how to use function calling to do that, to verify the query that it produces and make sure that it is working. So here's the example using function calling. The idea here is to use the function calling feature to invoke a custom function to execute the query that the AI produces and verify it that it actually produces the expected output. Let's see how it's done. Let's import the packages that we require. Again, same, the OpenAI API key and some other things like we're going to connect to an actual MongoDB instance and then execute the query. So we need the connection string, the DB name, and the collection name. I've set this up in my Mongo Atlas. We can do it locally as well. It should work. So I'm loading all those things from the environment file, creating a client. Here's the custom function that we would use for function calling. So it's named verify query, and it's inside a tools array first of all, and the type is function, and the function name is verify query, and we have got the description that says this function is used to verify that the MongoDB query produces the expected output data for the given user input. Input of this function should be the fully formed MongoDB query. That's a clear description for the function that we have. We've got two input parameters. One is input data, which the user provided, the sample input in JSON format, expected output, again, user provided. MongoDB query is the one that the AI produced, right? The aggregation pipeline stages. So what this would do, it will take the input data, insert it into the Mongo Atlas database, and execute the query against it. And then once it gets an output, it would take that output and then do a comparison against the user given expected output and see if it matches. If it matches, then the AI produced the proper output. We would return the response back to the user. If not, we'll again ask the AI to try producing a different query that could generate a proper expected output. So let's run this. Just like previously, we'll write a simple utility function to call the chat completion API. So here we are passing in a few more parameters, the model as usual, the messages array, the tools array, which contains this custom function. So we'll pass in the tools array, the tool choice, which is the actual tool within the tools array that we want the model to use always. So here we have got only one function. So we'll pass that function so that it always invokes that function before it returns back to the user. It will always verify the query. Temperature 0 and the response format is JSON object. So once we get the output, the response, we are getting the JSON output of it. And then from the JSON output, we are getting the message and the finish reason. These are the two things that this method would return for further down in the processing to check and do whatever we need to do. So it returns the message that it produced and the finish reason. Here's a quick little thing that we need to keep in mind. So in the chat completion API, there are two things. One, in the earlier version of the API,
there was this function call which is deprecated right now, and we are using tools. So when it returns and when it tries to invoke a tool, it would return back the tool name and the parameters to the tool, but then the function call will be null. By itself, there is no problem. But when we invoke the assistant again by passing in the message that it produced along with a next user message, then it would throw an error. Right now, it's throwing an error. So what we are trying to do is we are basically taking that particular function call thing from the response from the assistant message, so that when the next time we in the next iteration when we pass in another user message and call the um, chat completion API, it works. And then we are returning the assistant message and finish reason from this method. So let's run it. So here are simple utility functions to talk to the database, get database, insert the data, insert the input data, and delete the data. If there is data already existing in the database, we want to delete it before inserting the data. And then finally to execute the query on the collection where we inserted the data and the aggregation pipeline produced by the query. So these are simple functions to interact with MongoDB, actual MongoDB instance. And this is the custom functions implementation. We saw the definition there, and this is the actual implementation. So it has got input data, expected output, and the query. So it gets the database, it gets the collection, it deletes the data, it inserts the data, and then it executes the query and gets the result from the database. Once we get the result from the database, we can compare it against the expected output. In order to do that, we want to make sure that the JSON array is all sorted, the keys within each of those objects are sorted, so we can do a comparison and find out if the two JSONs, the result from the DB and the expected output, are they matching together or not. That's what we are doing here. We are sorting the two JSON arrays, expected output and the results from DB, and then returning the result of the comparison, whether it's true or false, right? So that's the verification custom function. This is the function that executes the custom function call. When AI decides to call the custom function, this is the one that gets invoked. And from here is where we call um, the actual function, the verify query here. So here we have defined three different responses that we would return back from this execute function call method, depending on what the verify query returned. It could be a success message, and the message says this query produces the expected output. It could be a failure. Then we would say this query didn't produce the expected output, or the error, right? So here we're checking if the message, the assistant returned the message, if what's the function name that we have got from that. If it's verify query, then we would get the arguments and basically call this function. So here we are using JSON 5. The reason to use JSON 5 is that sometimes when the chat completion API produces the query, it misses out the quotation marks, and then we are not able to parse it as a normal JSON. So in order to put back those quotations, JSON 5 was the easiest solution that I found. Everything else was too difficult. So if you give in that, JSON 5 is able to put it in the quotations and able to make it a proper JSON. Finally, we call the verify query, and it returns the boolean as we saw, compares it and returns a boolean, and then we return the boolean response. For some reason, it called a function, but it didn't call the verify query that we expected. It called something else in the tool call. Then we return an error message. The same data that we saw earlier. The system prompt is the same, but in the user prompt, a little tweaking. We want to make sure that the chat completion API understands there is a function, custom function tool that we have given it, and we want it to always use it to verify the query before returning back its response to the user, right? So first task is to write the query itself. The second task is to verify the query that it wrote using the custom function tool. Then always written in JSON. And then this is just something that I noticed. So explicitly stating, do not call the same tool twice. And this is what the JSON output is going to look like. And this is the input. There's one more prompt in the case of failure. Let's say it produced a query and we verified it using the custom function tool and found out that it does not produce the expected output. Then in that case, we wanted to say that we wanted to give this message back to the AI assistant and say that the query that you produced did not produce the expected output. So please try again, right? So that's this prompt. We'll use it if the query fails. Let's run it. This is a simple utility function that I got from one of the examples from OpenAI cookbook to print the messages from different roles and different colors so that we can easily see it. I liked it, so let's do that. So here's the core logic. We're going to put all the things that we saw above. The general idea is that we're going to loop it a few times, right? We can loop it any number of times. We can just leave it until it produces the expected output, but just I'm trying to minimize it to a predefined number of times that I'm looping, but we can just leave it unlimited time if we can wait it or define a timeout, whichever way we want to do it. But what we're trying to do is we're making the assistant try again and again until it produces the correct query. That's the idea. So we create the messages array as we saw earlier, and we pass in the system prompt and the user prompt, and then invoke the chat completion utility function that we saw above. So we are passing in the messages array, we're passing in the tools, and in the tool choice, we're saying which function, forcing the chat completion API to always use this tool when it is trying to produce a response, right? So we do that, and then we get from the chat response that we got from that utility function, we check the assistant message, and then we append it to the messages array to be passed to the assistant later. Now we are looping for the number of times that we have defined above, and then seeing if the assistant message that we got from the AI has tool calls, right? If it is trying to call, if it has decided to call the tool, then we would have this tool calls. It would say tool calls status. So we are checking for that. And if it's there, then we invoke the execute function call. So in the execute function call, we'll invoke the verify query function and then test the query against a MongoDB instance, get the output, and we'll verify the output, right? Once we have got the Boolean result, we're basically getting a message from that return response, whether it's a successful, whether the query produced the output or if the query did not produce the output, we're putting it here. Which tool was invoked and all that stuff. And then we're checking if the result is a failure. We want to append an user message along with the tool's output, right? We executed the tool and here's the output. That itself is in a message. Now we want to add if another user message if the result was failure. And the prompt that I showed earlier, asking the AI to try again to produce another query that could produce the expected output. That's this one. Once we do that, we call the chat completion API again. If let's say the result was not failure, then we basically leave it with the tool's response, which says it produced the expected output. And then the assistant can just return back what we need in the JSON format that we had instructed it to produce. And then we do this thing in a loop until we see that the assistant is not calling the tool. Basically, it's finishing and it is giving the actual response. Then we basically break out and use that response. So finally, once we are out of the loop, we are checking if it's still calling tool calls, meaning if it was again and again failure and we completed it 3 times, or we completed the time that we want to wait, and then we still see that it is calling the tool, then we basically take it from the argument and form our output that we require. Or if it actually produced and properly came out with a successful response, then we take the content directly. This is for failure scenario. It was trying again. This is for a successful scenario. Now let's run this cell and see. If you see here, this is the first time that we invoked system prompt, the user prompt, and then here's the assistance response. It is calling the tools. It is giving us the arguments and the function name. Now we executed it. The results matched. It says true. So this is the message that the tool. This is the message from the tool response that we would add to the messages array, and we'll call the chat completion again. So if you see here, this was the previous assistant response, and this is the function response that we added to the messages array, and then the assistant produced the output that we were expecting, which is the query and the explanation for that query. And we end with that. So this is one way to make sure that the query produced is accurate. And the logic that I used is to loop for a predefined number of times. But as I said, we can do many different things to however we want, whichever matches our use case or whichever we are happy with. Now that we have seen how to do this using chat completion API without function calling, chat completion API with function calling, and verify the query, we'll see how to do the same using the assistance API and see how that works. Okay, now let's see how to do the same in assistance API. We'll start with without function calling and then we'll use function calling and see how to do it. Let's import the packages. All of these steps are the same data that we were using. And within the prompts here, instead of the system prompts, we are using an assistant instructions. We are calling the assistant a MongoDB expert who can produce write queries for any given data and produce for any given data to produce an expected output. Let's run the cell. In the user prompt, it's again a simple one. We are asking it to write an aggregation pipeline specifically, and then return a JSON response. MongoDB query and the query explanation are the attributes that we are expecting. One thing to note is that Assistant API does not have that response format. It does not support it. So we would have to ask the model to do it, but there's no way to force the model to do it. And then we get the generated user prompts along with the injected input data, output data. Let's move on to create the assistant. Here we use the beta.assistance.create to create an assistant. We'll name it MongoDB SME. And then we'll pass in the assistant instructions that we saw above and the model. Once the assistant is created, let's store the assistant ID in a constant. We would use it in the example further when we would update the assistant to have certain tools to do that verification part. So let's use the same assistant to do it. In order to do that, in order to update the assistant, we need the assistant ID. So we'll save it. So let's create the assistant. And To interact with the assistant, the way we do that is we create a thread and then add messages to the thread. Thread represents an user session. Basically, the whole conversation of an user is contained within that thread. And that's how they provide us the persistence. The message array is not managed by us, the message array is internally managed, and that's done within a thread. So let's create a thread and then let's create a new message. Pass in the thread ID for the messages to create, pass in the thread ID, the role user, and the user prompt. We have got the thread, we have got the message. Now let's invoke the assistant on that thread. So to invoke the assistant, we are going to use something called runs, and we're going to create it so that invokes the assistant. We pass in the thread. The thread contains the messages and the actual assistant itself. Now let's run it, and we will have to poll for the assistant's response. Basically, the run would, once we have executed, the run would go into a queued state, and then it would go through various status. Finally, it would reach the completed status. So we are basically looping it through. Here I've defined 60 number of times we loop it for, and then for between each interval, between each iteration, we sleep for 2 seconds. So it's like we are looping for 2 minutes, and then saying that, and trying to retrieve the runs status every 2 seconds to see if it has reached the completed status. If it has reached the completed status, that means assistant has done its job, returned a response, which we can take it and do further processing on. So that's what we are doing here. We keep on retrieving the runs status every time, every loop, and then we check if it's in the completed status. If it is in the completed status, we retrieve the messages and then break. We sleep for every 2 seconds. And if you see, the assistant produced the JSON that we are expecting, the similar aggregation pipeline and explanation. So this is cool. We've got what we wanted. The only thing is that since we are not able to force the assistant to produce a JSON output, it gave us this prefix and the suffix, which we have to parse it out. So instead of that, let's see if we can in the next step, let's see if we can get rid of those things. So in order to do that, we'll use again a function calling feature. We'll use a custom function tool and force the assistant to use the tool each time. And when it uses the tool, it needs to produce the arguments to that function, and those arguments are well defined, and then we can generate a JSON response from it. That way we basically use function calling to produce the JSON output that we require. We are not even writing the actual implementation of this one. We're just defining this function and passing it to the assistant, and then getting the response from the arguments that it generates. So it's the same, the properties are same that we saw earlier. Or no, we saw input, output, and stuff like that. So here it's just MongoDB query and query explanation that we are asking it, and we are saying format the response before sending it. So that's a tool that we are adding. So if you see here, we are updating the assistant. Last time we created the assistant. Here we are updating the assistant. We are using the same assistant constant that we stored above, and then we are updating it with a tools array, and we are passing in a function tool. Let's run it. And then we're defining a new user prompt. We're just changing it because we are doing we want the assistant to call the function tool, so we want to mention that. So here we are saying your job is to write up aggregation pipeline just like previously, but then we are asking it to always honor it. So we're putting the important statement to format the response, always using the format response tool before responding to the user. So that way we are instructing it to call the format response tool each time. So we got the user prompt. We're creating a new thread. Same thing, we are adding a single message, and then we are invoking the assistant by calling the run. Similar concept, we are running it for 60 times, 2 minutes basically, and then getting the response. So here, if you see, last time we were checking for completed status. Here we are forcing the assistant to call the tool that we passed. So whenever the assistant does that, it decides to call a tool, it returns a status requires action. So we are looking out for that, and then we are seeing if it's that, then we are retrieving the arguments from the tool calls zeroth index array. Okay, for some reason it has errored out and then it has retried again. So that's good. At least I've not seen this previously, but yeah, this is something that I'm seeing right now. Something happened between the assistant run and then I think it tried again. So that's a good thing. At least the code works. So it produced the MongoDB query in the JSON format that we were looking for. So that's cool. We've got it, so we can parse it and use it. So this is one way to force the assistant to produce a reliable JSON format using the function calling feature. But then last time we saw that with chat completion API, we were able to use the function calling ability to verify the query. So we'll do the same here. So in the assistant, still now we use the function call to format the response. We really did not execute the function itself, the custom function. Right now we'll do that in order to verify the query, right? So again, the same function. The definition is different. Execute the MongoDB query, and the name is different. Otherwise, it's the same MongoDB query and the query explanation. And this is the definition. Here I have not gone into the details of writing those utility functions to interact with the MongoDB atlas and stuff. We can look at the previous example for that. Here I'm just mocking the response. If the function was called, what would happen? And I'm returning a success response here in order to keep it simple. Again, updating the assistant, the same assistant, and this time updating it with a different tool, execute query function. Okay. A quick utility function to create the thread, add the message to the thread, and invoke the assistant. Basically, create the run object and invoke the assistant. And the one that we were looking at, polling the assistant's response, polling the run's status basically by looping it. So we have got that inside a small function, and we are checking for, we are retrieving it again and again, and and sleeping for a regular time interval, and we're checking if the status is completed or the status requires action, right? If it's completed, then well and good, we've got the final answer. If it requires action, then we would have to call the custom function that we have provided to verify the query and then return the response. So let's run it. Again, the use of prompts, instead of saying format the response, here we're saying execute the query. That's the only difference. And then here is the main logic, similar to chat completion API. We are looping it 3 times. We can loop it any number of times, or we can let it run unlimited number of times and then do a timeout. We can do any which way. The idea is to make the assistant produce a query that produces the expected output. Until then, it can keep on trying, right? So we do that. We call it. We call the process user input function. Process user input basically creates a thread and invokes the assistant, and then we within the loop, we call the get completed run and get the updated run status. Either it's completed or it's requires action. So we got to check it, right? So if it requires action, then we have to invoke the tool. So we get the tool, we get the function name, we get the function arguments, and then we call this execute query, the custom function that we saw, which we have mocked right now. And it will always return success in our case. But if it's an actual implementation, it can either return success or a failure or an error, right? Anything. So if it's a response is success, then we break break out of this loop. If it's not, then we submit the tool's response, which is with the tool call ID, and the generated MongoDB query did introduce the expected out a custom message that we put in and inside the thread, and then invoke the assistant again, right? If it was, let's say in the success scenario, if it was called again, it would return the run status completed. So we would basically get the messages from it and use the text dot value, which would be in the expected format, the JSON format that we have instructed, and then we can keep going. So let's see how it works. So we see here, first time it tried calling the execute query. These are the arguments that it produced. And because we return success always, the next time when the assistant was called, it returned the MongoDB query, which is this one. The response is success. So we are just breaking out of it. We are not looping again because we got a success response. So we are getting it from the arguments. If we didn't get it, then we try and invoke the assistant again by passing in the tool's output. That's it. So we saw three different ways to use OpenAI to produce MongoDB query for a given input and an expected output. I've put the Jupyter Notebook links in the description. I will also have an article written about it. So those links will be present in the description. Feel free to check it out. Until next time, take care.